Ever had a cool idea for a gadget, or maybe some interactive art and thought, man, how do I actually build that? Well, today we're going to pull back the curtain on the tool that makes it all happen, Arduino. Think of it as a little creative toolkit for bringing your wildest ideas to life.
So let me ask you something. You see all these amazing projects online, right? Gardens that water themselves, custom robots built in a garage, art installations that light up when you walk by. What's the one thing that connects all of them? You guessed it, the secret sauce is Arduino. This one little board is the brain behind a ton of incredible stuff. We're talking robots, drones, entire home automation systems, IoT devices, even high-tech farm management systems. The sky is literally the limit. Okay, so what is Arduino, really? At its core, it's an open-source platform. That's a key phrase. It means all the designs and software are totally free for anyone to use, share, and improve on. The whole point was to make electronics accessible to everyone, not just engineers. To really get what Arduino is all about, you gotta look at the hardware. And there's no better place to start than with the absolute classic, the board most people begin with, the Arduino UNO. So let's take a quick tour. And here it is, in all its glory. Now I know it might look a little complex at first with all the chips and pins, but don't worry, we're gonna break it down piece by piece, and by the end, this thing is gonna feel a lot less intimidating, I promise. First things first, we need to give it some juice. The UNO gives you two super easy ways to do that. You can just plug it into your computer with a standard USB cable, that's port number 1 right there. Or, if you want your project to run on its own, you can use a power adapter with this DC power jack, which is number 2. Now, right in the middle of it all, you see that big black chip? That's number 11, the ATmega 328P microcontroller. This is the brain of the whole operation. Every command, every calculation, every instruction you give it, it all happens right inside this little guy. So, how does the brain know what's going on in the world? Well, that's where these pins come in. This group, labeled 10, are the analog pins. They're perfect for reading sensors that measure a spectrum of values, things like how bright a room is or the exact temperature. And then over on the other side, marked as 15, we have the digital pins. Now, unlike the analog pins that read a range, these guys are all about simple on or off states, a 1 or a 0. These are your go-tos for things like checking if a button is pressed or, just turning a simple light on and off. So remember, analog for range, digital for on/off. Okay, so we know about the pins. Let's zoom out a little and talk about the cool stuff we can actually connect to them. This is how we go from a simple circuit board to a project that can actually sense the world and, more importantly, do stuff in it. And really, it all comes down to two very simple ideas: input and output. Input is just information going into the Arduino's brain. And output, that's any signal the Arduino sends out to make something happen. That's it. Input and output. The parts we use for input are called sensors. Think of these as the Arduino's eyes and ears. Their whole job is to take something physical from the real world, like light or pressure, and turn it into an electrical signal the board can actually understand. And there are so many different kinds of sensors. It could be a simple push button, a photoresistor that detects how bright it is, a thermistor for temperature, or even an ultrasound sensor to measure distance. You can even use a variable resistor, which is basically just a fancy name for a volume knob. So what about the other side of the coin? For outputs, we use things called actuators. Now, if sensors are the Arduino senses, then actuators are its hands, its voice, its way of affecting the world. They take a command from the board and turn it into a real-world action. So what kind of stuff can an Arduino do? Well, it can turn lights on and off, obviously. It can spin motors, make sounds with speakers, print messages on little screens. This is the part where your digital code becomes a physical reality, which is just so cool. Okay, we've got the hardware, we know how to sense things and how to do things, but how do we actually tell the brain what to do with all that information? Well, that brings us to the software side of things, the code. And this is where you'll do it. This is the Arduino IDE. Think of it as your command center. It's a simple little program where you write out your instructions. And in the Arduino world, you don't write a program, you write a sketch. I love that term. It feels so much more creative and playful, doesn't it? Now here's the best part about learning to code for Arduino. No matter how huge or complicated your project gets, every single sketch you ever write is built on the exact same simple two-part structure. Get these two parts down, and you're golden. First up, you have the setup function. This bit of code runs one time and one time only, right when you power on the board. This is where you do all your prep work, like telling the board, hey, this pin is for a sensor and that pin is for a motor. Then you have the loop function. And just like it sounds, the code in here runs over and over and over again, forever. This is the main part of your sketch, where it's constantly checking its sensors and controlling its actuators.
All right, so you've got the basics of the board, the code. You know how to make it sense and do things. So what's next? Well, the next step is to go bigger. To connect your project not just to the room it's in, but to the entire world. I mean, think about it. What if your smart garden could check the weather online and decide not to water the plants because it's about to rain? Or your project could send a tweet. That's the whole idea behind the Internet of Things, or IoT. And yeah, Arduino can totally do that. To get your project online, you've got options. On the left, there's our old friend, the Arduino UNO. But check out the board on the right. That's a NodeMCU. It works a lot like an Arduino, but you see that little metal square on it? That's a Wi-Fi chip, built right in. That one little addition is a total game changer. So there you have it. We've taken a tour of the hardware, we've talked about sensing and doing, and we've even peeked into the world of code and the internet. The entire Arduino toolkit is right there. It's accessible and it's incredibly powerful. So really, there's only one question left to ask. What are you going to create?